Hello, my name is Jacob Dent, and I work as an undergraduate researcher under Dr. Akella. Today we're presenting the work of improving exploration graph generation for robot exploration. An important application for robots today is to send them into environments that are dangerous or hazardous to human life. In these environments, such as a burning building or a nuclear disaster site, we want to try to minimize the amount of time that first responders are spending in there. One way of doing this is by having a robot go in before them and autonomously explore and map out the environment. Now, if we want to have a robot that's autonomously exploring on its own, it needs to be able to create its own motion plan. One way of doing this is by creating something called an exploration graph. In an exploration graph, each node represents an open position that the robot can be in, and each edge represents a clear path between two nodes. In prior work done by Dada and Akella, we can see that one way of creating these graphs is through Zhang's skeletonization process. You skeletonize the map that's coming in from the LiDAR, and then through a series of processes, we can turn that skeleton into a graph, and then we can identify the frontier nodes. Now, doing all of this is a really costly function, and this takes time for the robot to process. We propose in this work an alternative way to building these exploration graphs is by using something called probabilistic roadmaps, or PRM for short. The PRM algorithm is a sampling-based algorithm designed for static workspaces. However, with a few modifications, we can get it to work for the application we have here for exploration. The maps that PRM create, or the graphs that PRM create, are not only more efficient than the skeletonization process, but about comparable in usage. And by creating these graphs more efficiently, we can have the robot exploring quicker.